Hi, I'm Mark, and this is my talk where I'm going to tell you you're doing it wrong. We'll find out if you're doing it wrong first. But no, this is OpenAPI, you're doing it wrong. And to start off with, what is OpenAPI? OpenAPI, it started out as a thing called Swagger. And Swagger was a way of describing your API for consumers so that they could build clients for it and interact with it and all this sort of stuff. And people always say it's a way of describing RESTful APIs, which is wrong. RESTful APIs describe themselves. You don't need OpenAPI if you have a RESTful API. The problem is that no one does have a RESTful API. No one has ever had a RESTful API. REST isn't a thing. We have HTTP APIs with JSON and sometimes XML, and that's what we're dealing with. And OpenAPI is a way of describing those. And so OpenAPI 2.0 was called Swagger. And then when Smart Bear said, we're donating Swagger and we're making it an open standard and everything, and it became an OpenAPI 3.0, which is kind of the current version, but there's an OpenAPI 3.1. And I'll talk a bit about the difference between 3.0 and 3.1. When I first started doing this talk, I was recommending to people use 3.0 because the 3.1 tooling wasn't really there yet, but it's got a lot better since then. So now I'm saying use 3.1. And actually, the lint tool that I have built into Visual Studio Code also says use 3.1. It's actually got a regular expression on the version tag that looks for 3.1 something. So yes. This talk is specifically for .NET developers because as far as I'm aware, the rest of the world actually does do this right. So this is for .NET people because we are doing it wrong. Because when we talk about OpenAPI in .NET, we talk about Swashbuckle and NSwag. Mainly Swashbuckle because Microsoft seemed to sort of bless Swashbuckle and include it in the box in .NET New and new API projects. But there's also NSwag. And what these do is you decorate your code with attributes and bits and pieces, and then at runtime it goes and it analyzes using a built-in thing called the API Explorer, and it generates OpenAPI.json files, which you can then serve through the Swagger UI. And this ends up, if you do this properly, you end up with more attributes in your controllers or more tacked on method calls on the end of your app.mapGet or app.mapPost, and then you do .produces response type, .produces response type, and you actually end up with more of these attributes and sort of documentation functions than lines of code that go to the database, get the data, turn it into JSON and send it back. And it's just ridiculous. And then you also have your doc comments with your summary and all this sort of thing. And it just gets ridiculous. And the rest of the world, the rest of the tech industry, your Node people and your Java people and Go people and everything else, for all that, you know, they are wrong because they're using Node or Java or Go, they write their OpenAPI specs by hand, usually in YAML, because you can write it in YAML or you can write it in JSON. YAML apparently is a subset of JSON or a superset. You can put JSON in YAML, which is weird. And they handwrite their OpenAPI document, and then they build the system to match what they've written in the OpenAPI document. And I just think that's a better way round to do it. And so I know we've got Swashbuckle and I know we've got NSwag, but I don't think we should use that. I don't think they're bad at what they do. I think what they do is bad. Does that make sense? I'm not criticizing the tools because they're bad tools. I'm criticizing them for existing, really. And with huge apologies to the people who've put enormous amounts of effort into Swashbuckle and NSwag. And actually, NSwag still has some great stuff because it generates clients and skeleton application things from OpenAPI specifications. But there's a lot of good stuff in there. But Everywhere else, it is handcrafted artisanal YAML files. I'm getting old. I'm 50. I have been doing this now for, not this talk, but I've been working in tech for 33 years now. And when I started, we were writing applications to run on Xenix and Unix on 80 by 24 dumb terminals connected over RS-232 cables. And we were essentially translating program specifications into C. And there were standards for creating specifications like SSADM and Prince2. And these specs would include pseudocode. So it's like, when this happens, it will do this, and then it will save this to the database, and so. And you would just basically go through and turn that into the arcane C instructions that would make that work. And at the time, the problem was that the specs, you could have all the standards you wanted, but you could still get specs that made no sense, that there was no way of translating what you had done into, or what they had specified into code. And we always used to sit around in the smoking room because everybody smoked in 1990, and all offices, some offices you could just smoke at your desk. It was brilliant. Other offices, you had to go and sit in a room with other people and smoke. And actually you could save money on cigarettes because you didn't need your own cigarette. You could just go and sit in the room. It was brilliant. But we would sit around and we'd complain. And one of the things we would complain about was that translating from pseudocode in an SSADM spec into C was boring. And we're like, surely you could just get a machine to do this. What we want is specs that compile. And that seemed like a far-off dream in those days. But with OpenAPI, what you actually have is a spec that you can compile. You can run it through a compiler. You can generate a client. You can generate a skeleton application, and so you can validate that your specification is correct and makes sense. And while you're editing it in Visual Studio Code or whatever editor you're using, you can get the little squiggles that say, no, this doesn't go here, and you can't do this, and you've forgotten this property, and all this sort of thing. And that's what the OpenAPI document should be. It shouldn't be something that your application generates to say, this is how I work. It should be something that your team writes to say, this is what the application is going to look like. And the thing that actually triggered this talk, the reason I was like, nope, I've had enough. I was working for a company in the UK, lots of microservices, financial system, credit cards, all this sort of thing. And so they had about 20 teams, all working on one or two services, maybe 3 services each. And so every GitHub repo had a spec.md file in it. And there was a standard sort of template for creating this. And what that spec.md file was all the endpoints that there should be, the shape of the objects that should be going into those endpoints. And so while they were sitting around and doing the design of the API, they were capturing these requirements in Markdown. And Markdown's great. Markdown's fantastic for lots of things, but it was handwritten Markdown. And then they wrote the code, and then they decorated the code with all the attributes, and then the Swashbuckle generated the Swagger document, the OpenAPI document. And it's kind of like, why have you gone round in this? Why didn't you just write the OpenAPI spec by hand? And then you could generate the Markdown from the YAML. You can generate documentation from the YAML or the JSON very, very easily. You've recreated OpenAPI in Markdown using heading levels for sort of paths, and then within that you have a subheading which is get, and a subheading which is put, and a subheading which is... You've reinvented OpenAPI in Markdown. And so I started going around going, can we just write the OpenAPI spec by hand? And I did actually get a couple of teams to adopt this, and they went, yeah, you know what, that's a good idea. What they did was they ran their code, they downloaded the JSON file, translated it into YAML, checked it into GitHub, And then the really brilliant thing was that they went through what had been generated and they added comments and they added descriptions that were missing and examples that had been missing from their code. And there is a way to include all these things using attributes and comments and bits and pieces in your code, but it's really hideous. And some of them involve just adding a huge amount of code inside your app.add_swagger UI or app.add_swagger. But this, if you create an OpenAPI.YAML file and you have it in your GitHub repo, that becomes the source of truth for your team. That is your specification. It's what you design to. It separates design and implementation. So as you're doing your sort of week of brainstorming and event storming and whatever else it is that you're doing, you can be capturing that design into a structured document, and you separate that design and implementation thing. And then you've got that document and it's in your GitHub repo. And when another team comes and says, hey, we're going to need to call your service, and you say, well, it's not ready. And they say, but can we get a client description so that we can start working with that? And you can say, yes, here it is. This is what our application is going to look like. This is our API. You don't have to say, oh, no, you'll have to wait until it's completely finished so that we can run it, and then you can navigate to /swagger and download the JSON file. And like I said, it has a better description of your API. It's got description tags. And the description tags can contain markdown. And you can actually describe how your API works rather than just going, yeah, no, there's a path and it's got a parameter and this is what the request body looks like and this is what the response body looks like. You can describe it much better and you can put comments in there as long as you're using YAML and not JSON. And nobody wants to handwrite JSON anyway, so yeah. And you can generate automated documentation from it. And I'm going to show you how you can do that in a GitHub action so that you can publish a really nice HTML documentation that it's not interactive like the Swagger UI, but it's something you can sort of publish as a static site. I've done a lot of stuff with gRPC over the last few years, workshops and everything else. And gRPC in .NET, the way it works is with protobuf. Now, there's a way of doing gRPC in .NET, which makes it look more like WCF, where you implement your service in .NET, and then it generates the protobuf file. And I blame WCF, by the way, for all of this, because we had WCF and we didn't have to worry about the WSDL file and the XML schema, because it was just generated for us. And so we came to expect that. But this is the protobuf. I just copied and pasted this. This is from the Google APIs repository. They have a money type because protobuf's native primitives only include float and double. And if you go to the financial sector and say, yes, represent money as double, they will run screaming for an alternative solution. And so this is essentially, this is the decimal type for protobuf, but also with a currency code. And within the this is what you would give to somebody who wanted to generate a client to talk to your Google API. And within this, we've got comments. We've got this represents an amount of money with its currency type, the 3-letter currency code defined in ISO 4217. And this is what automatically generated things tend to be missing, is this communication from human to human about how this actually works and what you're doing with it and how to turn it into a normal number or whatever it might be. And OpenAPI looks basically like this. So we have at the top, we have our version, and then we have an info section where we can put, okay, this is the name of the API, this is what version it is. If you have a problem with it, then you can contact me. This is me, this is my email, and then we have some tags that go in there. Tags is something that Swashbuckle and NSwag tend to not do very well. We'll see how those work. So I'm just going to run through quickly how OpenAPI breaks down and how you would go about writing it by hand. So at the top level, we have paths. And paths is like /read/books. And then within the path, we have operations, and we have a get, and then we say the operation ID is get books. In generated Swagger, that would be the name of the controller action. If you're using ASP.NET Core MVC, if you're using minimal API, then you actually have to tag on a thing that gives it an operation ID. And then we can put a summary in there, and we can link it to one of the tags we've declared earlier, and we can say what kind of responses it gives. And responses are basically just JSON schema, but represented in YAML, because you're writing it in there. And this is where that difference comes in from OpenAPI 3.0 to OpenAPI 3.1. So 3.0, it looked like JSON schema, but it did a couple of things differently. There were things that you could do in the OpenAPI description of an object that weren't JSON schema. There was a lot of stuff you could do in JSON schema that OpenAPI didn't understand. In OpenAPI 3.1, the JSON schema is JSON schema. It's the same standard. That's basically the difference. And we have, this is an object, and it's got an ID property, which is a string, and a title property, which is a string. It's got a finished at. This is for an API, by the way. I use it as an example application in workshops and things like that, because there's a very common sort of sample application like to do to-do lists. And my wife's a big fan of to-do lists. She's got to-do lists all over the place. And most of the to-do lists are like write a to-do list. I hate to-do lists. I find them oppressive and stressful. And so I created an app which is a done list. So when you've done something, you go, I did it. It's finished. It's called done that. And yes, so that's where this is saying, I've read a book. And this was the title of the book, and this was the author of the book, and I finished it at this time. And this is a string, because JSON doesn't know about dates, but we can say format, date time. And so then that will tell clients that actually they're getting a date time back, and it helps with validation and that sort of thing. Now, obviously, a lot of the time, you're going to have objects which are used with more than one API endpoint, customer, book, run, whatever it might be. And so you don't want to be repeating that in all those different places. And so we can also reference things inside our OpenAPI specification. And we can put a component section down at the bottom of the file, which has a schemas section. And then within there, we have all our different objects, which have names. And we can also have an example section in components. And we can reference things in external files as well. So if I have one of those laser things on here. No. That. So hash means it's in this file, it's down at the bottom, like an anchor tag in an HTML page. Whereas if that's like /, then it'll look for a file relative to the current file. We have parameters, and parameters look exactly like they do in our app.map or our controller HTTP GET attribute. So we say there is an ID parameter, and it's in the path, and you can also say it's in the query or in headers. And we can have a schema for the parameter, so we can say the type is string, or you can say the type is number. You can specify minimum and maximum, and say it's a date. You can say it's a UUID format. You can put a regular expression in there that validates it, all that sort of thing. You can say, is it required? So if it's a query parameter, this is particularly useful, because sometimes you have query parameters, but you do have to send them. And it makes clear that it is a required parameter. And then we have requests. So when you're doing a post or a put, you have a request body. And so here we have a post, which is the operation ID is add book, summary, add a completed book. Summary, by the way, is where you can put markdown. So you can have multi-line content in YAML, and you can put a complete markdown paragraph in there to talk about how this should be called and used and all this sort of stuff. And so our request body content application/JSON. This section here, so we got content and then we say application/JSON. You'll also get that on the responses, and that is saying this is the content type. So if I return JSON, it's going to look like this. You can also put application/XML in there or different media types. And we can say it needs to have a title and an author, and both of those are required. Otherwise, you're going to get a bad request. So components go down at the bottom of the file, and that's where you put all your reusable objects, your shared objects, that sort of thing. And in components, you can put schemas, responses, request bodies, parameters, headers, security schemes, OAuth or bearer tokens or whatever it might be, examples, links, and callbacks. Those last two I'm not sort of particularly clear on, but the headers and so forth I will show you. And so you just have a component section. Components is a top level property in your YAML file. And then within that you have schemas, and then you have another one for examples and all that sort of thing. And then you reference those with those $ref properties at other points in the file. So yes, references look like that. And if you want to put things into a separate document, then you can put the /schema and so on. So I'm just going to show you this in context. So here is the OpenAPI file, handwritten, perfectly meticulously crafted by me. And I'm just going to make that one step bigger. So yes, you can see we have tags. We got books and authors and distances and users. We got security, which is auth0, which is defined later on. And then we have our path, and we have our operation, which is get books, gets a list of books that I have read. It returns component schemas list of books, and there's an example list of books. And so I can control click this, and it will take me down there. And list of books is just an array where the items are of type book, and then I can control click book, and I will get taken down to there. And so I can just put all my information about my objects in there. The descriptions of the objects, so in here, I can also put a description, a completed book. That's actually something that Swashbuckle isn't very good at, is because we don't decorate the data transfer objects with attributes for Swashbuckle to be able to describe them. And so when we see the descriptions of objects, they're not very good. But the thing it's really terrible at is examples. So here we have some examples, and we have a list of books, and the value of that would have an ID and a title and an author, and these are actually valid, those are real books. The examples that you see in Swagger UI tend to be property name, and then they just put the type in, or a randomly generated date, or the current date, or something like that, and it's not a meaningful example of what you can send to the API. Whereas if you do it this way, you can put in realistic examples. What else do we have here? Okay, so yes, here we have external references. Now, a 201 created response, if you're writing an HTTP API and you're doing it the kind of purist way, when somebody does a post, it doesn't return any content. It returns an empty body and a location header, which tells the client where it can go and then make a GET request to get the object that has just been created. And we also, quite often, if somebody sends us some JSON and it doesn't make sense, or it's missing a field, or you can't pass a date or something, then you're going to send some sort of bad request response. And can I? No, I can't control click in there. I will just have to go into responses. And you can see here we have a record created. This is our 201 created response. And we say this has a location header, and there is a reference to the headers folder here. And then we have a location.yaml, and we have a description for this, the absolute URI of the created record, and the schema type is string there. And you can actually build up a sort of library, like a template, where these responses and headers for your standard responses and headers are predefined, so you don't have to recreate them every single time. We look at bad request here. You can see we have the content type is application/problem plus JSON. And actually, if you only take one thing away from this talk, if you come out of this talk going, no, screw that, I'm carrying on using Swashbuckle, at least try to make sure that when you're returning a 400 add request, you set your content type to application/problem plus JSON, because it is meaningful in the world of APIs, and it tells the client that the content of that message is going to conform to a particular standard. The standard it's going to conform to is validation problem details, which is an object, or has a property errors, which is an object. And then it's essentially a dictionary. It's a field and then a string saying what was wrong with that field or something. And you can see we actually have inheritance in JSON schema as well, because this object includes all of the properties from problem details.yaml. And we have a type, a title, a detail, a status, which is your 400 or 409 or whatever it might be. Instance is a unique identifier for this request. So you could use something like the activity ID from your distributed trace, your correlation ID or something. And then you can have extensions on there where you can put whatever the hell you like, and people can just do what best they dealt with, they think. And then we have an example of this down at the bottom here. We say the type, and you see this is actually an IETF RFC, and standard title, status 400, and a trace ID going in there as well. Which shouldn't be trace ID, it should be instant. There we go. So yes, let's go back to our OpenAPI.yaml file. So we're just about to talk about security, and security goes down at the bottom here, and we have our security schemes, and the top level there is the name of the security scheme, and then we say the type is OAuth2, and we can say it supports these flows. And again, this is something that's difficult for the automated generators to extract out of your application, because you can't it can't go, oh, I see you're using JWT authentication. Whereas in here, I can actually say, okay, you have the implicit flow. That is an actual live URL. I have a trial account on Auth0. They keep sending me things going, how's your trial going? Do you want to upgrade to a paid plan? And I'm like, no, it's just for a talk. I've told you before. But yes, so this, in your Swagger UI, which you still have, by the way, you don't need Swashbuckle or NSwag to get the Swagger UI included in your application. It will actually let you click over to that, log in, come back to the Swagger UI, and then make test requests against the API. And we also have client credentials if you're accessing it from a service or a desktop application or a mobile application or whatever. But those are the actual URLs where you can go and get authentication token. Problems. We literally just looked at problems. So the application/problem plus JSON, that's a standard. It looks roughly like that. And then we actually have validation problem details. So to make it more correct, I separated it out because problem details could just be various things about the request. You didn't include a header or whatever it might be. The errors part, it goes into validation problem details, which is there was a problem with a property in what you sent, and this is what it is. Okay. So I am going to yeah, okay. OpenAPI 3.1 is not perfect, and we can highlight the problem with it quite easily. So if we look at a post operation, so here we're in our path /read/books, and we have a post operation ID, add a completed book, and it has a reference. It doesn't allow for polymorphic endpoints. So you actually have endpoints in a lot of applications where the URL is the same, but you could post a PNG or a JPEG or a video file or a JSON document or a PDF. You could post lots of different content types to that same endpoint, and different things will happen as a result. And in OpenAPI 3, there's no way of describing that, because all you have is your path and then your operation, your method, your HTTP method, and then what that does. So there's no way of saying that does multiple things. And so some of the OpenAPI team are working on OpenAPI 4, which is currently called Moonwalk for some reason. And you can see the work in progress at github.com/OAI/Moonwalk. And this actually switches things around. So where previously under our path we had post, instead we have a requests section, and then what used to be the operation ID becomes an actual property in the YAML, and then we say this is get books and this is the method, and then everything else is basically the same. And so that's where the twist is. Rather than going, there is a single post, you go, here are the requests. There is a request called get books. There is a request called post book. There is a request called post video of me reading the book, but it goes to the same endpoint as the post book. So this, hopefully, this will actually turn into the current version of OpenAPI at some point soon. That would be nice. And then there are the tools that you can use with this, and we're all familiar with Swagger UI because we've all built an API and included Swashbuckle and hit run, and it goes to the /swagger endpoint. But there's also tools for generating HTML documentation from that OpenAPI.json file. There's redoc, which is github.com/redocly/redoc, and there is elements, which is lovely. I'm going to show you elements in a minute. And the way I am going to show you elements, I'm going to go to the GitHub repo. This is the GitHub repo for this talk, github.com/rendlelabs/buildstuff2023. The API is in there, the docs are in there, the slide deck is in there, everything is in there if you want to grab it. But we also have a GitHub workflow in here, and we have our main.yaml here, and let's big this up a bit. So yes, I have my OpenAPI.yaml file in my GitHub repository. It's versioned. If someone wants to change the specification of the API, they have to open a pull request, and then we can fight about it in the pull request comments. This is the other advantage of pulling it out and actually having it as an upfront document. And then that YAML file is in our GitHub repo, and so we can have a GitHub action step that says run npx redocly/cli bundle openapi.yaml. So what that does is it takes that openapi.yaml file, it finds any external references, and then it copies them into the bottom of the document and turns them into internal references, because the documentation pages won't follow links inside those YAML files. So then we put that out into dist/dundat/openapi. So that's our bundled YAML file. And then we just have a deploy, GitHub pages deploy action, which publishes it onto the GitHub pages for that repo. So rendlelabs.github.io/buildstuff2023. That's the standard GitHub repo. So you can set that up. This is elements. I really like elements, okay? And I'm going to show you a couple of things that I like about it. So because I wrote my spec by hand, and I used those tags, my endpoints are broken up into sections. So I have a books section and a distances section and a users section. And then within books, I've got my operations here, get list of completed books. And you can see here that we have the security is OAuth2. There's the authorize URL and the credentials URL. And over here, we have a request sample and a response example. So there's my list of books example that came from my YAML file. And if I click here, you can see JavaScript, Node, Python, Go, C, Objective-C, OCaml, C#, Java, HTTP, all these different things. And so if I go to C# and then let's see what it says for HTTP client, it actually just, this is the documentation. And this is a single HTML page, by the way, that is using web components in really effective and inventive ways. Yeah, you copy and paste that into your application and you've got it working with an HTTP client. Or if you prefer to use REST Sharp, then you can go down here and you can say, what would it look like with REST Sharp? Damn sight easier. But yes, so this is elements. And this is just a static HTML file, like I say. And so that combines with the OpenAPI.yaml file that was built as part of the GitHub action. And I can put a link to this on the README of my GitHub repo, and people can just go over there and they can follow the docs and copy and paste code for Ruby and whatever else they want to do. So, plugins. Rider actually has the OpenAPI specification built in, and I'm going to show you that in a minute. VS Code, there are multiple OpenAPI extensions for VS Code. The one that I use, that seems to be the sort of most up-to-date and best supported, is 42crunch.vscode-OpenAPI. So that's what is giving me lints and control-click to follow link and so forth inside my Visual Studio Code experience. So bundling, Redocly is a node application. You can either do an npm i-g redocly/CLI, or you can use npx, which downloads the internet onto your computer, runs it, and then deletes it again. But yeah, you can use that to bundle your OpenAPI. I am working on a .NET bundler that will do the same thing, and I'm working on a .NET lot of things. These are the packages that I'm working on, and this first one is on NuGet. I think it's still sort of pre-release, but it does work. And then I'm also building analyzers, because one of the things that people say is, but at least if you're generating the Swagger from your code, it's accurately describing what your application does rather than what you say it should do, which just seems messed up to me, because that just means you're wrong twice. And if you've got your spec, your structured, linted, compilable specification, you can at least be sure that that's right, and it doesn't matter if Dave has forgotten to set a property on one of the objects. But I'm working on an analyzers project where it will look at your OpenAPI.yaml file, and then it will look at your minimal APIs, and it will look at your controllers, and it will say, does your implementation actually match your specification? And it will generate warnings, and then you can set those warnings as errors, and ensure that these things are working. And then there's bundle, which is essentially that Redocly bundle command, but written in .NET, so you don't have to install Node and dirty your machine up. And OpenAPI.test, which lets you write tests that look like the spec. So you put, here is the request, here is the endpoint, and here is the expected response, and then you can hook that into XUnit or NUnit, and it will just run those as automated tests using in-memory testing and everything else. And then there's another thing, going back to protobuf, when you include that protobuf file in your gRPC project, it generates a base class for the service, and it generates all the protobuf message types, the models as well. And then you just inherit from that base class and implement the different members. And if you don't implement, they're not abstract, they're virtual. And if you haven't implemented one, it will literally return a not implemented exception in RPC speak. So I do have a code gen thing. And like I say, I think NSwag already has a thing where you can have the spec and then generate the skeleton, but it's a one-shot thing. It only happens that one time. So I'm working on a code generator that generates a base class that you can then inherit from, and a base class per tag in your OpenAPI spec. And if you haven't implemented an endpoint, it will return. There is an HTTP status code 50 something which is not implemented. Sorry, 501 not implemented. So yes, it will generate those not implemented things. But then you sort of inherit from that, and it automatically has the right parameters, and you can do dependency injection with it and all that sort of thing. And then if you change the spec, it regenerates that base class. Then you get compile errors if a parameter's been added or something like that. And then there will be code that lets you hook that up using minimal API, so you can run it in a container or Azure App Services or whatever, or wrappers that also make it work with Azure Functions, AWS Lambda, all that sort of thing. That's going to be good when I finally find the time to finish it. So openapi.web in your code looks like this. So we have our startup code here, and we've commented out add a endpoints API Explorer and add Swagger gen because we don't need those anymore. And we go down to here, and we've commented out app.useSwagger and use Swagger UI. And we've just added in app.useStatic OpenAPI. And then we pass in an assembly. We've just got the OpenAPI.yaml file as an embedded resource. And then we've got some options here. The UI path prefix is going to be Swagger, the JSON path, the YAML path. So it automatically translates to JSON if people want JSON from the YAML. Not easier than it sounds. Microsoft have a very good OpenAPI library that you can use for that. And then you can also specify elements and what the path you want for elements, and it includes that lovely elements HTML. Redocly is also supported because it's quite easy to support that as well. I just much prefer the look and feel, and Redocly doesn't give you those language drop downs to change the request example. And yes, if I run this, it will happen very slowly. I've got a framework 16 on pre-order, which I'm really looking forward to. Not least because this laptop doesn't work when it's not plugged in, which is great. So there you go. This is this application with its static YAML file, but this is the Swagger UI, same as usual. If I click authorize, it will let me go over to the implicit flow thing there. And if I go to v1/docs, then we get the elements documentation built into our application as well. Now, to be fair, there's nothing that would stop you from including elements in your application, and this would work with your generated Swashbuckle or NSwag OpenAPI.json. So I'm being very honest telling you that. It would be so easy to say, you could only have this if you do it my way, but you can do that the other way as well. And that is basically it. And by the way, alongside this, OpenAPI inspired AsyncAPI, which is a very similar thing, but for describing messaging. So if you're using Service Bus or SQS or pub subsystems or Kafka or anything like that, then you can use AsyncAPI to describe your producers and consumers, and that works really nicely too. Okay, cool. Thanks very much. I will see you around.